It is 2 a.m. You told yourself you would put the phone down 20 minutes ago. You are still holding it. Your thumb keeps moving almost on its own, pulling one more piece of content down from the top of the screen. You are tired. You know you should sleep. But the real reason you cannot stop is far stranger than simple bad habit. What is happening in your brain right now has almost nothing to do with willpower, and almost everything to do with a reward system that is millions of years old, wired by a piece of technology that did not exist 20 years ago. Start with a basic question. Why does this particular activity feel so hard to stop when so many other things you do all day are easy to put down? You can usually finish a meal. You can usually end a phone call. But scrolling has a strange, sticky quality that other habits do not. To understand why, you have to look past the app itself and into the machinery of anticipation. In the middle of the 20th century, the psychologist B.F. Skinner ran a now famous series of experiments on pigeons. He placed them in a box with a lever, pecked the lever, and sometimes a small food pellet would drop. But Skinner varied how often the reward appeared. Sometimes it came after one peck, sometimes after 5, sometimes after 20. The birds could never predict exactly when the payoff was coming. What Skinner discovered is that this unpredictable pattern, what he called a variable ratio reinforcement schedule, produced the single most persistent, most compulsive behavior he had ever observed in an animal. Pigeons on this schedule pecked far more frantically and far longer than pigeons who received a reward every single time. Certainty, it turns out, is boring. Uncertainty is what keeps a creature pecking. What made Skinner's discovery so important was not just that unpredictable rewards worked better than predictable ones. It was how dramatically better they worked, and how resistant the resulting behavior became to disappearing entirely. Pigeons trained on a fixed schedule, where a reward always came after a set number of pecks, gave up quickly once the reward stopped coming altogether. But pigeons trained on a variable schedule kept pecking for a remarkably long time after the rewards were removed completely, sometimes thousands of pecks with nothing to show for it. Their history of unpredictable payoff had taught them, on some deep behavioral level, that the reward could always be just one more peck away. That same principle, incidentally, is the exact mechanism behind why slot machines are built the way they are. It is not a coincidence that the same reward structure shows up in a casino floor and in the palm of your hand. Now think about your phone. Every swipe down the feed is a peck at the lever. Sometimes what appears is boring. Sometimes it is mildly interesting. And every so often, without warning, it is something genuinely funny, surprising, or emotionally charged. You never know which one is coming next. That unpredictability is not a bug in the design. It is the entire design. This connects to something deeper happening in your brain chemistry, and it is not quite what most people assume. For years, popular science oversimplified this into the idea that scrolling simply floods your brain with the pleasure chemical dopamine. But the neuroscientist Robert Sapolsky, in research building on decades of work studying reward systems in primates, found something more precise and, honestly, more unsettling. Dopamine does not spike mainly when you receive a reward. It spikes hardest during the anticipation of an uncertain reward, in the gap between the action and the outcome. In Sapolsky's studies, monkeys trained to expect a reward after a light appeared showed dopamine surges not when the treat arrived, but during the uncertain stretch of waiting to see whether it would. Remove the uncertainty entirely, make the reward completely predictable, and the dopamine response actually drops. Your brain, in other words, is not chasing satisfaction. It is chasing the feeling of almost. That single mechanism explains an enormous amount about why 2 a.m. scrolling feels less like enjoyment and more like a low-grade compulsion. You are not really searching for the good post. You are running on the anticipation of the good post, refreshed every second or two by a new possibility. The mild disappointment of a boring photo barely registers, because your brain has already moved on to anticipating the next swipe. There is a second layer to this, one that has nothing to do with psychology and everything to do with basic biology. Light itself is a signal your body has used for hundreds of thousands of years to know what time it is. Specialized cells in your retina detect brightness and wavelength, and relay that information directly to a small structure in your brain called the suprachiasmatic nucleus, which regulates your circadian rhythm, the internal clock that tells your body when to feel alert and when to feel sleepy. Blue-enriched light, the kind emitted by phone and tablet screens, sits close to the same wavelength as daylight. Your body, evolved entirely without electric light, has no real way to distinguish a screen at midnight from a bright morning sky. A study conducted by researchers including Anne-Marie Chang, published through Harvard-affiliated Sleep Research, compared people reading on light-emitting devices before bed to people reading printed books. The results were striking. The screen readers took significantly longer to fall asleep, produced measurably less melatonin, the hormone that signals your body it is time to rest, and reported feeling less alert the following morning, even after a full night in bed. Your phone is not simply keeping your mind busy at 2 a.m. It is actively telling your biology that it is daytime, suppressing the exact hormone your body needs to shut down. What makes this particularly relevant to late-night scrolling specifically, rather than just late-night screen use in general, is the posture and proximity involved. Reading an ebook before bed is one thing, held at a modest distance with a relatively steady image. Scrolling holds the device closer, tends to increase overall screen time because the format is designed to be consumed quickly and repeatedly, and keeps your eyes moving and refocusing constantly, all of which increases total light exposure to the retina over the course of the session. The same Harvard-affiliated research found that the delayed melatonin release did not just cost people time falling asleep, it measurably shifted their entire circadian rhythm later, meaning the disruption did not end when the phone finally went down. It carried into the following day. Put these two systems together, and you get something genuinely difficult to escape. One system in your brain is chemically rewarding the uncertainty of what comes next. Another system in your body is being told, through raw light exposure, that it is not actually time to sleep. Neither of these systems asks for your permission. Neither one cares that you have work in 6 hours. They are both simply doing what they evolved, or in the phone's case, were engineered to do. Here is the part that reframes the whole experience. None of this happened by accident. The specific rhythm of infinite scrolling, the way content refreshes with a small delay, the way a new post slides in just as the last one fades, these were not arbitrary design choices. They were built, tested, and refined by people who understood exactly what Skinner discovered about variable rewards and exactly what neuroscience has since confirmed about anticipation and dopamine. The gap between your thumb movement and the new content appearing is not a technical limitation. In many cases, it is a deliberate pause, long enough to build a flicker of anticipation before the reward, real or not, arrives. This does not mean you are weak-willed for finding it hard to put down. It means you are a human brain encountering a system explicitly engineered to exploit reward circuitry that evolution built for an entirely different purpose. That circuitry once helped your ancestors persist through uncertain foraging, checking one more bush, one more riverbank, one more patch of ground, because the uncertainty of where food might be next kept them searching instead of giving up. The same wiring that once kept a hungry forager moving through a landscape now keeps a tired person moving through a feed at 2 a.m., long past the point where any real reward is likely. Consider how well-suited that ancient foraging circuitry actually is to a task like scrolling. A forager who gave up searching after the very first empty bush would starve. A forager who searched forever, past all reason, wasted energy that could have gone toward rest or safety. Evolution, therefore, needed to tune the system carefully, rewarding persistence just enough to keep searching through short stretches of nothing, powered by the memory that reward had shown up unpredictably before. Your feed exploits that exact tuning. Each individual scroll costs you almost nothing, a fraction of a second, a flick of the thumb, so the system that evolved to weigh real physical costs against real physical rewards never receives a strong enough signal to say, stop. There is no ache in your legs from another mile of walking, no fading daylight warning you that safety is running out. There is only the frictionless motion of a thumb and an evolutionary alarm system that was never built to notice when the cost of continuing dropped to nearly zero. There is a strange kind of relief in understanding this. The struggle to put the phone down was never really a referendum on your self-discipline. It is closer to a mismatch, an ancient uncertainty tracking system and an ancient light sensing system, both doing exactly what they were built to do, now aimed at a piece of glass engineered by teams of people whose job was, quite literally, to make disengagement as difficult as possible. Knowing this will not instantly make the phone easier to put down tonight, but it changes what the moment actually means. The pull you feel at 2 a.m. is not proof that something is wrong with you. It is proof that two very old systems in your body, one chemical and one biological, are responding exactly as they were built to respond, to a signal engineered with more precision than either system was ever designed to resist. So the next time it is 2 a.m., and you tell yourself you will put the phone down in 20 minutes, and you are still holding it 20 minutes later, you will not need to wonder what is wrong with you. You will know exactly what is happening. It is not weakness. It is an ancient reward system meeting a modern machine built to trigger it on purpose every single time you swipe.